Let's review something, gang. I'll put a ball here, a little spring gun, and another ball here. And as you know, when I release this, both balls will fall at the same time. Did I not demonstrate that to you? Let's try it again. If at first you don't succeed, why try again? Okay, no sense being a fool about it. Here we go. And indeed, they hit the ground at the same time. And the rule there is gravity doesn't take a holiday in moving objects. Let's suppose I just dropped them. What would happen? No surprise. But you know, to some people, it's a surprise that they do hit at the same time when they're fired. Now I'm going to pull it back further. Still the same time? That's got to be level, gang. And watch. Still the same time. The time it takes to drop has to do with how high it is, not how fast it's going sideways. We learned that? And how far it's going to fall down will depend on how long a time. Does anyone remember the relationship for how far down will it fall as time goes by? Can I give you that relationship right here? 5t squared. Remember that? So in 1 second, how far will an object fall if you drop it? 5 meters. It'll fall 5 meters down. If you threw it straight out, would it continue straight out or would it fall below the straight out point? Let's suppose, for example, you got in a tower. And let's suppose it's 5 meters tall, where you are right here, and you just drop an object. You just, boom. How long it take to hit the ground? 1 second. Let's suppose I instead throw the object. How long does it take to hit the ground? Let's suppose I throw it faster, sideways. How long does it take to hit the ground? 1 second. Because what it's doing, it's falling beneath the straight line it would take if it didn't fall. Isn't that right? And that vertical distance from here to here, that vertical distance, 5t squared. So 1 second to fall 5 meters. Let's suppose I threw it really, really fast, so fast that the curvature of the world played a role. A second or longer than a second? Longer than a second. Can you kind of see that? Because let's suppose I talk about, here's my straight line. It might be 5 meters here, but here's going to keep getting more and more and more than 5 meters. So it will be in the air for a longer time when you take Earth curvature into account. Because we live in a curved world, don't we? Isn't the world curved like that? And if you had a cannon at the edge of the beach and you grazed it right out so it was grazing right against the water, and you fire a cannonball, if there's no gravity, of course, it would just continue straight, 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 and pretty soon the water would be below it, yeah? Do you know how far out you have to go on the planet we live on before there's a 5-meter drop? Check your neighbor and see if you're sitting next to someone who happens to remember that fact from your reading or from previous lectures. How far out do you have to go along the Earth to get a 5-meter drop?